Hi, today we're going to go over the notes for Pre-Calculus Chapter P, which stands for Prerequisite 1, which is the first one. The title is the Cartesian Plane, and then you're going to write your first and your last name and what period you're in. The best would be to put it in a spiral notebook or a notebook that you have. If not, you can use any piece of paper. Just make sure you keep your notes in a folder because you're going to be allowed to use them on any tests and final exams that we have. Okay? All right. So today we're going to be talking about the Pythagorean Theorem, and most of you have heard of the Pythagorean Theorem before. It's a squared plus b squared equals c squared. On here it's written backwards, but that's fine. So a and b are always the two shorter, what we call legs, and then c is always the longest side, called the hypotenuse, and it's always opposite the right angle. Depending on which angle you're which side you're missing is going to depend where you put your variable. So on this first one, we're missing this side right here, which we'll call c, and it happens to be the hypotenuse. So I plugged it in for c squared, and then plugged in the other two sides for the legs a and b, and then simplified my equation. So 5 squared is 25, 11 squared is 121. Add those two together, you get 146. And then the inverse operation of squaring is square rooting. And then the square root of 146 as a decimal is approximately 12.0830. If that's what you do when you have the hypotenuse missing. But what if you have a leg missing? You plug it in for either the A or the B, in this case, A. So I put 20 in for the hypotenuse for C, 15 in for B, and then left the A in there. So 20 squared is 400, 15 squared is 225. Subtract the 225 from both sides, which gives you 175. And then the inverse operation of squaring is square rooting. And you get 175. So you can either do it as a simplified radical or as a decimal. So it depends on how you're asked for your answer. If you're asked for a decimal, just give it like this. If you're asked for a simplified radical, you would realize that 175 is the product of 7 and 25. So the square root of 25 is 5. Okay. All right. Here's some few harder Pythagorean theorems. What you're going to notice is these have radicals in them already. Okay, so when you have radicals and you square them, they become what's inside. So the square root of 6, when you square it, becomes 6. When you multiply the square root of 6 times the square root of 6, you get the square root of 36, and the square root of 36 is 6. All right, same thing happens with 2 rad 15. 2 squared is 4, square root of 15 squared is 15. So when you go to simplify, you multiply the 4 times the 15 because of order of operations. You get 60. You add the 60 and the 66 together to get 66. And then you take the square root of 66. You can either change it to a decimal if the directions tell you to, but this is already a simplified radical because the only factors are, what, 2, 3, and 11? Okay. All right. You can also do it with the hypotenuse plugged in. So if you take the hypotenuse of 12 rad 7, you plug it in for the C side, the 5 rad 30 in for A, and then solve for B. So 12 rad 7 times 12 rad 7, 12 times 12 is 144. Square root of 7 times square root of 7 is 7. 5 times 5 is 25. Square root of 30 times square root of 30 is 30. So order of operations says we need to multiply here and multiply here. So that's a pretty big one with the 1008 and 750. So you subtract the 750 from both sides and you get 258. And we're going to leave it as that simplified radical. All right. The other topic covered in this section is the Cartesian plane. So we're going to be talking about the standard equation, or what we call the standard form of the equation of a circle. And so the standard equation is x minus h plus y minus k equals r squared. That r stands for radius, And the other two important variables in here are the h and the k. That h and the k are going to make up the center of your circle. There's no number here for your h or your k. That just means that it's at the origin and you had a 0 and a 0. Okay, but usually you're going to have numbers. For instance, on this one right here, if the center is at 6, 2, we're going to plug in a 6 for the h and the 2 for the k, and we get, oh, and we have to plug in the radius. The radius is 1, 2, 3, 4. So 4 squared, because that's what the equation, standard form of the equation calls for. And then we just simplify. 4 squared is 16. Okay? All right, so there's a couple things you're going to do with that. All right, so for this one, they want you to find the center and the radius. So if there's a 2 here, that means your ordered pair for your center is going to be at 2. But right here you have a +1, which is actually the opposite of that because there's a minus in this standard equation. And so your y part of your ordered pair is -1. So the center should be at 2 to the right, down 1, put a point. And then the radius would be the square root of this number. 64, square root of 64 is 8. Usually this number is larger, and then you'll remember to take the square root. The only time it's going to mess you up is like if it's a 4. So you have to take the square root of 4, and that would be radius of 2. So that one might trick you up a little bit. Make sure you just take the square root of this number, count out 8 in each direction, and it looks like it should make a square, but you would just make a circle through all 4 of those points. Don't include that radius, obviously, or the center. That center needs to stay in the center. All right, so what if you have fractions in there? Fractions are fine too. So the center for this one would be the opposite of this number, which is -5/2. And then this one's tricky because it looks like they messed up, but no, nothing's being added or subtracted. So that's why there's a 0 here for this ordered pair. Okay. And then right here, we've got a 7. So it looks like they messed up again, but they actually just want you to take the square root of 7, which if you get it as a decimal in your calculator, it's 2.6. That's just a little less than 3. So our center is at -5/2, which is -2.5. So you go 1, 2.5 to the left. 0 means you don't go any up and down right here, and put a point for your center. Then remember the radius was 2.6, so just a little less than 3 each direction, up, left, down, and right. And then draw a circle through all 4 of those points. Okay? All right, what do we got here? Find the standard form of the equation. So this one's a little bit easier. We're just going to plug in these numbers. Now, if you have a negative, when you plug it in, you have minus, minus. So you're going to change it to plus. And then this one is a plus, so it's just y minus 4. Radius of 15, so you plug in 15 and you square it, and you get 225. All right, let's try another one. Plug in 6, so it's x minus 6 squared. Plug in -2, so minus minus. You're going to end up having a plus 2. And then 2 rad 5. You want to square that 2 rad 5. 2 times 2 is 4. And then square root of 5 times the square root of 5 is just 5. So 4 times 5, that's where the 20 comes from. Okay. All right, now we're going to talk about the distance formula. So the distance formula is this big, long square root thingy. Okay. And that's how you find the distance between 2 points. So here's point A, here's point B. So they'll just say find AB. Okay. That means they want you to get the distance between those points. So you can either use that distance formula, plug in your numbers, your x value minus your x value and square it, your y value minus your y value and square it. You'll get 25 plus 4, which is what, 29? Or you can drop this point down and then take this point over and create this right triangle. And then use the Pythagorean Theorem, because you can count this side's 2, this side's 5. So just use 5 squared plus 2 squared. You'll get the same answer, square root of 29, square root of 29, which is a decimal of something like 5.3852. Okay. The other one, the other formula is the midpoint formula. Midpoint formula is finding the middle. Okay. So you're just going to add your 2 x values together and divide by 2. Add your 2 y values together and divide by 2. So in this case, you'd add the -4 and the 5, which gets you what? 1. So divide that by 2, 1/2. Then you're going to add the y values together, the -7 and the -3, so -10. That one is divisible by 2, so -5. Now when it's on a Cartesian plane like that, and it's somewhere in between the 10 and the 10 by 10 frame, sometimes you can count it out and you can see where it's going to land and that you're pretty close to where it's at. But if you have larger numbers that's off of that grid, the standard size grid, you can use that formula. Okay? All right. If B is the midpoint of segment AE, find the coordinates of E. So if we have A and B, we can, and you have a Cartesian plane, you can actually just count from A to B. You go 5 over, up 2. So if you go over 5 and up 2 more, you can figure out where E's at really easily. So you just count over and up, and that one's at 8, 8. But if you have numbers that are larger, like -102 and 104 and -110 and 112, you're probably going to want to use the formula because you're not going to be able to draw a graph that big. Okay? So here's how you would use the formula. If M is at -102, 104, and F is here, what do we need to get? Find G. Okay? So we're going to say that, which one do we do first? Okay, so this is the endpoint. M is the midpoint and F is one of the endpoints. Okay, so we're going to say that F, which is the -110, plus the other endpoint that we don't know, we'll call it X in this case, is going to be equal to -102. And the Y, 112, plus the other y, which we don't know, so we'll call it y, divided by 2 is going to be equal to the 104. So we're going to separate this to find our x and our y separately. So if we have the x minus 110 over 2 equals -102, multiply both sides by 2, those cancel right there, and we have x minus 110. Multiply 2 times -102, we get -204. Add 110 to both sides, we get -94. You can see how this would be really hard to do on a graph. And then for the y value, same thing. Multiply both sides by 2, subtract 112 from both sides, and you get 96. So that other endpoint, G, is going to be at -94, 96. All right. Okay, so this says, here's another one that's not going to fit on your, see how these graphs go from like -10 to +10, -10 to +10. So this one's not going to fit on there. You couldn't necessarily draw this one easily. So center is at 22, -7. 22 is going to be way over off that grid. So we're just going to say that the center is at 22, -7. Take the square root of 36, get 6. And okay, we're almost done. All right, the standard form of the equation. So we need to find this, so we're just going to plug in 5 for this value right here, -8 here, which a negative minus a negative is plus. And then we're going to go backwards of square rooting, and we're going to square the 11, which is 121. And then if we know the center is at 6, -2, and we know a point on the circle, we can actually calculate where that's going to be at. So we're going to take the 6 and plug it in here, the -2 and plug it in here. And then we know one of the points, so I'm going to plug that -2 in here, that 5 in here. And guess what? We haven't got the radius yet. So we simplify. -2 minus 6 is -8. When we square that, we get 64. 5 plus 2 is 7. When we square that, we get 49. Add those two together, and we get 113. And that becomes our radius squared. So we can just plug that number in. All right.